Welcome. Thank you guys for coming. I'm Daniel. This is the AI on Kubernetes tutorial. That's what I'm going to talk about. That's all I prepared. So if you don't want to hear about that, then there's a bunch of other interesting things around. But I'm pretty sure you guys are in the right place. Just a reminder, grab one of these IPs if you don't have them up on the front table. There's a link here to the tutorial materials. Those are the ones that we're going to be going through all day. They're on GitHub. Oh, it's a little feedback there. So go ahead and navigate there, and you can follow along. There's also a link. I'm pretty sure there's a link at the bottom of that repo, README, with a link to the slides. So if you also want to follow along in the slides or download them or share them or whatever, that's there as well. Awesome. So let's go ahead and get started. Let me give a little bit of an agenda. My understanding is that we have this. Yeah. I can't hear you. I'm sorry. Yeah, sure. And if you go to this repo, which is the first link, the link to the slides is way down at the bottom of that README. So if you want to follow along the slides, you need to catch up or anything, then you can do that. The agenda for today, we're just going to do a bit of intros, talk about some of the logistics of how things are going to operate in the tutorial today. Then we're going to jump in and talk about what we're talking about AI on Kubernetes, but if we're talking about AI on Kubernetes, what do we actually need to enable on top of Kubernetes to do AI on Kubernetes? So that's what we're going to talk about. Then I'm going to introduce some of the Kubernetes tooling that we're going to use for our AI workflow. And then we're going to, from there, just jump into the hands-on part. And we're going to all go through all of these things. You'll all be able to work hands-on with Kubernetes and deploy a full AI workflow on top of Kubernetes. And then we'll conclude, and I'll give you guys some resources. Are there any questions about the rundown for today? So just a little bit of an intro to me. I kind of have my hands in a lot of different projects, but one of the main projects I work on is with a nonprofit called SIL that does language and literacy work around the world. I'm a data scientist with them, and so I'm doing a lot of natural language processing and a lot of work to try to understand where and how languages are used and engaged with around the world. I also co-host a podcast called Practical AI. We're I think about 12 or 13 episodes in. We're going to be recording some live episodes here at the conference. So definitely check that out. I co-host that with Chris Benson, who's got a lot of experience. He was the chief scientist with Honeywell, and that's a lot of fun. I also do some teaching and consulting with a couple places, including Purdue University. Now, I'll leave this up for now. So again, go to these tutorial materials. I'm going to jump pretty much between these slides and those materials on GitHub. And all of the commands and that sort of thing that I'll be running are in this README. So you don't have to try to catch them or screenshot them on the screen. They're all going to be there, so you can copy and paste and follow along. But before we get into that, I'd love to just kind of get a sense of where everybody's coming from. So we're going to go around and everybody's going to introduce themselves and tell, no? All right, cool. Man, you guys really need to wake up. Let's get some smiles on faces here. Okay, so but I would like to know, so how many of you guys would consider yourselves software engineers? Okay, maybe like half-ish. What about data scientists? Do we have any AI researchers? All right, a few. Okay, so you guys are the ones. We can defer all questions to you guys, or the experts. What about data engineers? A couple. Okay. How many work with Docker on a regular basis? Oh, that's great. Yeah, like 1 or 2 years ago, if I was at this conference and I asked that, then it would be much different. And how many of you actually work with Kubernetes in production? 1, 2, 3, 4.5. All right, cool. So again, I'm kind of trying to narrow this down to people that I can defer questions to. So that's good to know. So for this, I'll kind of assume that quite a few in the audience are kind of familiar with Docker. Probably most are not familiar with Kubernetes. And that's kind of the stance I'll take for the day. But if you have worked with Kubernetes before, I think you'll be seeing a lot of new things throughout the day. So hopefully it'll still be interesting to you guys. All right. So let's go ahead and talk about some things before we get hands-on. So a lot of you guys are data scientists or AI researchers or the like. So if we're talking about some infrastructure for AI, what do we need to do with, or what do we need to enable on that infrastructure in order to effectively, develop and deploy AI workflows? What do you guys think? I'm going to be asking a lot of questions, so you guys just get used to blurting out answers. So if I have some set of infrastructure and I want to enable AI workflows on that infrastructure, what do I need to enable? What do I need? Docker, maybe. Let's say independent of any particular infrastructure, like logically, what sorts of things do I, like an AI researcher or whoever it is comes to me and they say, I want to do X. What is X? Yeah.
Workflow pipeline.
What now?
Workflow pipeline.
Yeah, workflow pipeline. Yeah, so AI workflows are typically not like single stage sort of things, despite what every example on the internet will tell you. Very often these involve a lot of different steps. So we need to orchestrate some sort of pipelines and workflows. Okay, what else? Scalable inferencing, okay? So what do you mean by scalable inferencing?
So be able to have hundreds of thousands of users inference the same model with their own data.
Yeah, so he said have hundreds and thousands of users be able to inference, be able to generate inferences or trigger inferences all at the same time. So we need to scale up our inferencing. What else? Resource management. And what do you mean by resource management? Okay, so he said dynamically allocate resources based on the need of the data scientist. So why do we need to have flexibility in the types of resources that we allocate for AI workflows? Anyone? What? There's a lot of experimentation. What else? You need a lot of processing power. So, and what's unique about the processing power that I need for AI sort of workflows? What? So I might need GPUs for training. Okay, I might need GPUs for training. Do I need GPUs for everything? No. So what do I not need GPUs for? Inferencing, maybe. Some inferencing uses GPUs. Pipeline. And by what other parts of the pipeline are there that might not need GPU? Data prep, data cleaning, pre-processing. And so what we find is that actually all of these different stages of our AI workflow, so there's training and pre-processing and inferencing and maybe other things. Each of those might require different types of resources than other ones of those. In other words, they might scale differently. So we need to be able to flexibly define and allocate resources for these different pieces of the puzzle. What else? Have we missed anything? What? Yeah, so, and what would we need to put in place for service level management? Scheduling, resource manager. I definitely need to schedule things, but I like the direction you're going. What's a piece? So we've talked. What? I'm sorry.
Storage for
So storage. Yeah, we need to store our training data, store our pre-processed data, store our serialized models, all of that stuff. Now, if I have my data stored, and I'm able to allocate flexible resources for training and inference and all of these things, and I'm able to schedule things, I'm able to pipeline things together, there's still something I think is pretty important that's missing. Access control. Okay, so this is getting to it. So he says access control. Why do you need access control?
So as a dedicated set of users, they can access something, but they should be restricted on some other set of data like non-public information data and say payment card, industry data, all those things.
Yeah, so he's saying that some data might be available to everybody. Other data like credit card information or personally identifying data or these types of things you might not want or be able to share with everyone. So access controls is important. There's still a piece that I would say is missing. Monitoring. Okay, so why do you need monitoring? To see how your training behaves, why else would you need monitoring? Job progression, what? A job running too long. Want to make sure your model's converging. All right, yeah, so all great answers from AI-focused people. What if I'm a lawyer? Why do I tell you that you need monitoring? What? Audit trail, yeah. So this is like a piece that you'll probably hear a lot about at this conference, mostly because people are actually thinking about it now. The AI workflows that we're generating now actually make an impact on people's lives. If you don't know that yet, you should. This is something that software engineers have been dealing with for a while, software that makes an impact on people's lives. Guess what? Your AI models make an impact on people's lives. And if you reject someone for insurance, you need to be able to know exactly what model was used to produce that particular result and how it was trained, on what data, in what way. You need to be able to explain what happened all along the audit trail to get to that particular result. Okay. In order to enable that sort of audit trail, what do we need? Say it again? Data lineage, repository. Reproducibility, and how would you have reproducibility? The same environment, automated test sets. Yeah, I think that all of this kind of generally falls into kind of reproducible environments plus some sort of versioning, right? That's really important. Okay, I've tortured you guys enough. This is how I've kind of represented it, or how I think about it in my mind. If you search for, production AI workflows on the internet, then you're going to find a bunch of, Jupyter notebooks that do this, right? Do some training on some training data with some configs and parameters, and then they maybe do some inference, right? So this is pretty much like the picture you see. But in reality, as we've already kind of parsed apart, that is far from the whole story with actually enabling AI at scale. You might have some pre-processing and some corresponding pre-processed data. You might also have some serialized pre-processors that you have to use both in training and in inference. You have maybe model export and model optimization. I was just talking to Chris up here before we started about model optimization and how you might even export models but then compile them and optimize them afterwards. You're going to have saved and serialized models. You might also have some post-processing. You might do some hyperparameter optimization. You might utilize some test data. Hopefully you're utilizing some test data and some validation data to make sure your model's generalized. And so very, very quickly you basically get into this scenario where you have all of this data and all of these pieces of processing that now you guys are telling me, okay, I need to stitch them together in some sort of workflow and be able to manage flexibly the resources associated with each one and be able to version the whole thing and have a complete audit trail. And now things start like getting maybe a little bit, I already see you guys are depressed again. It's like, no, just give us back our Jupyter notebooks, right? That's the happy place. But we're not going to stay there, so we're not going to stay in the depressed state. What I've kind of boiled down that we're going to shoot for today, which I think match up reasonably well with what you guys said, or at least get to some of that, is that we need a consistent, scalable, versioned way to deploy each step. And by consistent, I mean having to do with these like reproducible environments. We want to have a uniform way, even though all of these things might run on different sorts of resources, might have different sorts of needs, utilize different sorts of parameters. We want to have a consistent way to deploy all of those pieces. And we want that way of deploying things to be versioned so that we know what version of what is running where. We need a data storage solution that tracks changes in our data. If you're updating your training data set, if you're updating your parameters, if you're updating your serialized models, if you're updating your preprocessors, all of that affects the eventual provenance and lineage of what you're doing in inference, right? And so you need some way of tracking changes to your data in addition to tracking changes to your code. This is something pretty unique to the AI context. Okay, then we need pipelines or workflows that get the right data to the right code at the right time. I could also say, just a second. I could also say pipelines that get the right data to, or the right version of data to the right version of code at the right time. What was the question? So if you go to the repo that was posted right at the beginning, way down at the bottom, I think, of the README, there's a link to the slides. So one more time, this is the materials that if you guys just came in, these are the materials that we're working out of. The README in this repo, down at the bottom, it should have a link to the slides. And that's, so you can follow along there, but you also need to follow along from that README. Okay. And then finally, we need some integration with scalable serving frameworks that can serve our model, which is going to have different needs than what our kind of more batch training will require. All right, what questions are there about this? Concerns, snide remarks? Did I miss anything? All you guys are happy, or it's too early. You're really making me concerned.
We take into consideration to having a date of libraries, because if you are moving from one library to another, this type of consideration.
Yeah, definitely. So his question was, would you need to manage updates to libraries and that sort of thing? Yeah, I would kind of put that under under number one, where if we have a version and consistent way of deploying things, hopefully also, depending on what language, this will be language dependent potentially, right? We're either using a requirements file with Python, we've got those manually specified in a Docker file, whatever it is. We're using Docker tags to manage that, et cetera. Yeah, that's a great point. Any other questions or thoughts on this? Yeah.
Getting into what I call model morphing, where I've got people that are taking lots of models and combining them together. So keeping lineage at the model level as well is kind of problematic for me as well.
Yeah, that's a great point. So what he said is, you know, actually, I think very often having one model that you're managing and having the training associated with that model and the inference associated with that model is even a simplification, because oftentimes you'll have, you know, one model that does this, which feeds in data into another model that does this, and then et cetera, you have kind of layered models or even ensembled models that you're utilizing. So yeah, I think that I think when we're looking for a solution for this, what we want to keep in mind is that we want to have versioning at the model level as well. And essentially, how we'll treat that today is, you know, a model, especially a serialized model, is really data. So if we enable some sort of tracking of data changes, in theory, we could track model changes. Now, that might not be human readable. We'll get into that later. So that will be a good point. Other questions, thoughts? All right. So let's go ahead and introduce the Kubernetes tooling that we're going to be using for this. And how I'm going to talk about this is by talking about, okay, we've said that we might have kind of this set of, you know, hybrid or variable resources that we want to utilize. We might have a bunch of like CPU machines, some GPU machines, maybe other specialized types of machines that we need to run the various pieces of our AI workflow on various of these machines, depending on what the particular stage is. Okay? Now, if we want to be able to deploy each of these things, so each of these boxes up here, let's say it represents some Python application that does training or some application that does inferencing or whatever it is. If we want to deploy each of those on one of these machines, and we want to do that in a consistent way, what might be some ways that we do that? And in a versioned way. So we have our GitHub repo, okay, that's versioned our code. We have maybe our training script in there, and we can update it over time and see the changes, so that gets the versioning at the code level. Once I have my code version, then how do I get it running on one of these machines that's not my laptop? Docker, okay, a lot of you guys already mentioned Docker. Again, I'll assume that based on the show of hands, there's some familiarity with Docker in the room. So obviously, there's a lot of ways that we could do this. In the HPC context, you might, you know, create some queued job that runs your code or whatever it is. Let's also assume that here we're talking about like cloud machines, whether that's a cloud as in the cloud like AWS or an on-prem hybrid cloud or something like that. In those cases, oftentimes you don't use those sort of HPC batch systems. Now you could just create Docker containers for each of these things and deploy them on the various machines. And this is really good. So what's some of the advantages of using Docker to deploy each of these things on these machines? For you Docker experts out there. So say it again. So it's highly distributed. And what do you mean by highly distributed? Because distributed can carry some baggage, let's say, the word.
So the workloads can run on multiple machines in parallel.
Yeah, so she said the workloads can run on multiple machines in parallel. So in other words, I could take the same Docker image and deploy it to multiple machines in the same way without kind of modifying how I deploy it potentially. Now, if I'm doing something like distributed training, which we'll talk about here in a bit, it gets a little bit more complicated because there's communication involved between the various instances, but we'll tackle that later. What's some other advantages of using Docker? Dependency management, yeah. So probably you guys have seen the gradual progression of, like when I started working at my first startup, I had my friend DevOps Doug, let's call him, and I would tell him, hey, I'm running all this crap to do this stuff. You create like this Ansible script that's gonna boot up an instance, install my dependencies like scikit-learn and pandas and whatever it is, and then run my stuff. And that's okay, but it's not. Basically, he didn't like me because all my stuff was always different, and he had to always update his stuff. So if I'm always updating my dependencies, or maybe even worse, you know, I'm using Python for this and R for that and Scala for this and Java for that, right? This gets harder and harder. So what Docker allows us to do is similar to a VM, if you've seen this. So VMs came about, which kind of encapsulate an operating system and a bunch of dependencies, but then people found out that, oh, these things are not fun to manage because they're like 10 plus gigabytes each and like include a whole operating system. So what Docker said is, okay, let's strip out the operating system and use this concept of Linux containers. And what these Docker containers just include is your code, your dependencies, and an example, you know, file system that those run in. And whatever you put into those Docker containers are going to run consistently as long as you have Docker installed on all these machines. So by utilizing Docker, we have Docker installed on all of our machines. And if we Dockerize our applications, we can run them in exactly the same way on any of those machines, regardless of if they're written in Python or R or Go or Java or Scala or whatever it is. And all of our dependencies are now managed by the owners of the application. Okay, any disagreements, questions about that really fast crash course in Docker? All right. If you're interested in my GitHub, there's another repo. I forget what it's called. It's like called Docker for data science or something, and that'll walk you through some introduction to Docker and how to Dockerize Python applications and that sort of thing. Okay, so we have Docker. That's good. We can deploy each of our applications in a consistent way across our machines, and actually we can have some concept of versioned Docker containers, because Docker containers can be tagged with a specific version. And so we can deploy tagged versions of our things across these machines. So what's the problem? Why don't we stop here? Orchestration. So what do you mean by orchestration? Yeah.
If you're thinking in terms of divide and conquer, then you need the concept of strong clusters and so on.
Cool. Yeah, so I'll kind of summarize what you said into this, and that's that people found out about Docker, and then they were like, this is really cool, let's make everything Docker images. And then you have 1,000 Docker images, and you have no idea how to deploy your Docker images because there's so many of them, and you have to manage them, right? And so now what we have to figure out is, okay, for all of our AI workflows, or for even one, we might have pre-processing and training and inference and post-processing, which leads into another model, which leads into another model, which leads into other stuff and other stuff and other stuff. And very quickly, especially as you build up your AI projects, you get a ton of these things to manage, and it becomes hard. So it becomes intractable to say, oh, I'm going to log into each one of my machines that I need to run something on and run Docker run this image. And so we need a piece to manage that for us. So this is where, as you might have guessed, Kubernetes comes in. All right, so Kubernetes is basically an orchestrator piece that kind of strings all of our resources together. It manages all of our resources for us such that we don't have to log into each machine and say, I want to run this Docker image here. What we say instead is it's very declarative. So we say, hey, Kubernetes, I want 5 of these Docker images running somewhere. And now we don't even care about the underlying infrastructure. Kubernetes just says, OK, I'll make it happen. And it deploys those somewhere under the hood to some set of those resources. What questions are there about that? So say it again.
What is this fragmentation of resources where one particular, so there are pieces of these resources across multiple machines, but each job needs an aggregate?
Yeah, so that's a great question. So his question was, what if you have kind of fragmented resources? In other words, some of your machines have GPUs, some don't, right? Some are high memory nodes, some are not high memory nodes. And you need to run certain things on certain types of nodes. In Kubernetes, this is managed in a few different ways, but one of the main ways is with resource requests and resource limits. And so you can actually say, when you run something, I want 5 of these to run, and each of them needs a GPU. And then either it will schedule those on 5 available nodes with GPUs, or it will have those in a pending state until those GPUs are ready, and then it will schedule them.
So the box level is the GPU level, is it a tensor core level?
Yeah, that's a great question. So his question was, how granular can you get? And what I'll show today, and I'll kind of show some of the examples a little bit later, primarily what you get just out of the box is like memory storage, CPUs and GPUs like per node, and then it finds nodes that match that resource spec and then deploys there. However, there's a lot of efforts around, like, for example, NVIDIA has NVIDIA Docker, which is now more tightly coupled with Kubernetes. And that allows you to utilize some of their, first of all, their optimized NVIDIA Docker images, but also utilize, say, if your machine has multiple GPUs and you want to orchestrate those GPUs on a single, like one of those big boxes with 1 million GPUs on it, then you can better utilize that sort of thing. So it's progressing quickly. Other questions? Yeah. Uh-huh. Yeah, that's another great question. So his question was basically, what if you had something running already on Kubernetes on a certain type of resource, and then you wanted to update that? What you would do is, if we're just talking about like bare Kubernetes, you would update what's called the manifest for that deployment, which is essentially just a specification that tells Kubernetes, again, you're declaring, I want to run this on this type of machine. You would update that, and then you would just send that off to Kubernetes and say, apply this now. And what will happen is Kubernetes will now see, hey, I'm running things this old way, but you now told me that they should run this new way, like you updated your code, or it needs a different resource, or whatever it is. And so it will actually terminate those old running containers, and it will redeploy the new ones to the correct resources. There's various incarnations of that, including like rolling updates and other things, but that's the kind of basic structure of it. And we'll see that today here, actually. We'll do some updating to show you how some of that works with this tooling. Exactly, yeah. And really, there's also, his question was, what if you kind of added resources to your cluster and you want to use half on the old, half on the new, or something like that? And really, again, think of this as more of a declarative thing. Like Kubernetes sees this pool of resources. If you add more, it sees that pool of resources as having whatever resources they have, and it will deploy things there as you tell it to. Okay. Other questions? Yeah.
So one of the situations I see is that people may have existing clusters and you have vendor packages that are expecting it to be a unique cluster and not necessarily integrated into the existing cluster. You run into that?
Yeah, the question was, with some vendor packaging, it might look for like a specific cluster in a set of clusters or something like that. We can talk more like in the break about what specifically you have in mind around that. But generally, I'll just say that most vendors at this point are considering how to integrate their things with Kubernetes. Because if you guys aren't aware, Kubernetes 1. Everybody is either considering going to Kubernetes or already is going to Kubernetes as far as scheduling and orchestrating containers. Mesos switch, like you can run Kubernetes on Mesos now. You can Docker Enterprise runs Kubernetes. Everybody runs Kubernetes on every cloud. So I would say that vendors, if they're not there yet, they're thinking about it, and I could help with individual ones if you're wondering. Yeah.
What's your take on that about being able to manage multiple Kubernetes, right? Like even let's say I'm on a workstation and I have my own Kubernetes set up there across an entire enterprise. How can I manage the Kubernetes cluster that's set up on a workstation versus across the entire enterprise?
Yeah, that's a great question. So he said, what if, in general, what are recommendations around managing multiple Kubernetes clusters, which you might run locally in some sort of experimentation, and then a test cluster maybe, and then you're running something other in production, or you have multiple production clusters. Really, if you're not like running things in a federated sense, like you don't want to say like, I want to run this application across these 5 clusters. If you're just saying, I want to manage different clusters, then that's really just a matter of switching out your config locally to interact with whatever cluster you're interacting with. And even on an individual cluster level, you can utilize what's called namespaces to namespace like a certain set of resources and manage, or applications, and manage the resources associated with those applications. But then, yeah, there's various tooling as well, like, pretty much every cloud provider, along with Rancher and like enterprise solutions like Pivotal and everything, have their own sort of flavors of managing multiple clusters. But yeah, we can talk more about that. I'm happy to chat more about that in the break if there's follow-ups. Yeah. Yeah, the question was if you run something like in a VM versus running it in a Docker container, is there like a performance price to pay? I would say used to people had concerns about this. I don't think pretty much in every use case I've ever worked on, I've never seen that as a blocker in any case. And I think I'm not a Docker performance expert, so I'll qualify that, but I've never seen it as a blocker in these types of use cases.
Docker container is just a process on that machine. So the only overhead is the Docker engine itself. That's
yeah, and we can jump into this more in the break. Happy to talk, but yeah, it's I would say it's negligible in pretty much every case, and there are certain penalties to pay. Performance-wise, let's say the first time you run something and you have to pull the Docker image down to the machine, there's a latency, right? But if you're pulling down a VM, then it's going to be more latency. So Docker images are also better if you're wanting to spin up a lot of different things and tear them down quickly and spin them up again because they're much smaller. So. Okay, so we have Kubernetes. We're deploying all of our thousands of Docker containers, and we're all happy. Why is Kubernetes not enough for our AI workflows? Remember the things that we're wanting to enable. We're wanting to enable scalable, reproducible way to deploy things. We kind of have that, and then we want other things. So why is Kubernetes not enough? Okay, yeah, so it doesn't do any workflow management or pipelining. What else? Like on that front, you just say, I want this thing to run, and it runs it, right? There's no concept of, I want this thing to run, and then give data to this thing, which outputs data, which goes to this thing, et cetera, et cetera. What else? It doesn't version your data. Actually, it doesn't data, right? Kubernetes is completely stateless as it is. So like, I have nodes here, right? And those nodes might have hard drives attached to them or SSDs or whatever. But Kubernetes has no concept of managing data necessarily. Now you can create like persistent volumes that attach to certain things, but as far as like a general distributed way of managing your data, it's not really what Kubernetes tackles. What else? Access controls, yeah, so Kubernetes doesn't manage access controls. There's actually a bunch of layers like, access controls, service mesh, and a lot of other things that like, if you want to enable serverless types of interactions, there's a lot of layers on top of Kubernetes that are needed to enable those sorts of things. What about particularly in the AI context? So let's say I'm talking about, I want to run Jupyter Hub and have that be multi-tenant, and I want to run distributed TensorFlow across multiple machines, and I want to run, let's just take the distributed TensorFlow case. I want to run distributed TensorFlow on Kubernetes. How would I run distributed TensorFlow on Kubernetes? You guys are probably saying that's what this workshop is about. Why are you asking me? Give me a guess. Okay, yeah, great. So John, is that your name? Yeah. John said you need to start a parameter server. You need to start multiple workers. And so we could do that with Kubernetes, right? We could say, Kubernetes, I want you to run a parameter server, and it's going to pull a Docker image and run that parameter server somewhere in this cluster. And I want you to run 5 workers, and it's going to pull those Docker images and run it somewhere in the server. What's the problem? So it doesn't tell it what to do. Now I could tell it to run a certain script, like when the container boots up to run certain training. But so now we figured out how to run TensorFlow serving distributed TensorFlow on Kubernetes. If I was now to take a break and say, next exercise, everybody run distributed TensorFlow on Kubernetes, where would you get stuck? I've got a lot of blank stares, which I can interpret in a certain way, but. Yeah, so somehow I have to link these machines together. He was saying somehow I have to know the IP addresses and link these things together, which is really getting at what I'm going after, and that's basically it's too hard for me. I'm not going to do all that work. I'm not going to create this thousands and thousands of lines of config to say, I want a parameter server, and I want it running on this resource, and I want 5 workers, and I want them running on these resources, and then find out the IPs here, and then they communicate in this way and expose this DNS, and blah, 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 blah. I don't want to do that all day. Anybody else? So, it's really freaking hard. So established that Kubernetes can do it, and actually can do it in a really nice way because we can deploy all these things across nice flexible resources. We can auto-scale our clusters. We've got all sorts of great fault tolerance. If nodes go down, then stuff is rescheduled. We can update things, but it's still really hard because we're deploying all this stuff. There's tons of config, and so it sucks. So what we need is something like Kubeflow. So if you don't, I don't know, maybe some of you guys want to spend all of your days writing config. I do not. If you do not, then Kubeflow is a great kind of addition to this. So Kubeflow is kind of a layer that rides on top of Kubernetes. And what it provides, or what it attempts to provide, is a set of CRDs. So CRDs are custom resource definitions for Kubernetes, which basically means that it generates a lot of the config that you need to deploy certain types of AI-related things. Like it has custom definitions if you want to deploy like TensorFlow serving and TensorBoard and Jupyter Hub, multi-tenant, blah, blah, blah. It has definitions for all of those things. So if you deploy Kubeflow on top of Kubernetes, then you have this really nice set of definitions that you can utilize to deploy these things that otherwise would be really complicated and one-off. It also includes a bunch of packaging for all sorts of AI ecosystem things that you might want to run in your AI workflow. And it includes a bunch of example notebooks, as everything does that you will see for the next 3 days. So that's great. Kubeflow, if you want to look into it a little bit more, if you just go to kubeflow.org, there's a lot of information there. So this is great. This solves a lot of the headaches we have around all these sorts of custom definitions and config and all of that. Why is that not enough? So what left do we need? So it still doesn't solve access control. Like on the top part of this diagram, what am I missing that we haven't even talked about yet? Data. It doesn't solve any sort of thing about data, how I store it, where I version it, how I control changes to it, how I get data to certain things. Like I could deploy them easily now with Kubeflow, and I deploy my TensorFlow, distributed TensorFlow, and now it has no data, so that doesn't really get me very far. Okay. Also, like you guys have already said, I need pipelining and all of that stuff. I need serving. Kubeflow provides the necessary definitions to enable some of that, but I still need to make a choice for what am I going to use for pipelining, what am I going to use for serving, and I need to actually deploy those things on the cluster, right? So I've forgotten my data. And so now we just need to utilize Kubeflow and make a choice for the various data storage and versioning pieces, the data pipelining pieces, and the serving pieces that we're actually going to utilize. And Kubeflow, thankfully, has a lot of definitions for those and a lot of packages for those that we can use out of the box. Today in this tutorial, we're going to utilize Pachyderm, an open source project called Pachyderm. You can see I'm wearing this shirt for version data and for pipelining. And then we're going to use a project called Seldon, which also has many open source components for model serving. But these are just, I'll emphasize that these are just choices. I think that Pachyderm is very full-featured as far as what you get here. I think that Seldon is pretty quick to get up and running. But a lot of times you're going to want to use TensorFlow serving maybe. And you can utilize that. Or maybe you want to use PyTorch for training or something like that. Or you want to utilize some other workflow manager, maybe Airflow or something. Those are all choices. In my opinion, these are the quickest and easiest route to actually managing this at scale that currently exists. So that's what we're going to use today. So we're going to use Pachyderm for the version data and pipelining piece, and we're going to use Seldon for the model serving piece. We'll get into more of the details about those here in a second, but before we do that and we leave this world, are there any more general questions about this suite of tooling? Yeah. Yeah, so the question was, what do you mean by pipelining? Because one of your Docker containers could just publish things to Kafka. That was the question, right? I absolutely agree. So you could set up a bunch of queues or a bunch of other things that manage the messaging between your different Docker containers. I think, again, the problem there is that oftentimes this involves a ton of config, and oftentimes data scientists are really good at writing code that takes in a file, does something with it, and outputs a file, and not so good at creating robust software that manages asynchronous events off of a queue. So I think that there's definitely trade-offs in both cases. Here we're taking the perspective that we want to give the data scientists an interface that is data-centric. Like, you process these files and output these files. I'm going to manage the distribution of that, the versioning of that, the deployment of those pieces, all in a uniform sort of way, and not force them to learn a new tool necessarily. But I totally agree. And in some cases, you might be tied to Kafka already. Kafka can run in Kubernetes as well, and it could feed the pipelines that we're talking about today. But so we can talk about it more in a break. I don't want to get distracted necessarily from the route we're going, but I still think that, at least in my opinion, there's a lot of efficiency as far as development efficiency that you can get out of this. I think you'll see later that the interface might be very familiar for your data science team, but yeah, it's on a case-by-case basis, and in some cases you might want to run Kafka and other things on top of Kubernetes rather than what we're running here. Say it again?
What if something failed?
Oh, what if something failed? Great question. So we'll look at that a little bit more here in a bit, but the pipelining stuff that we'll deploy, and this is maybe another answer to the Kafka question, it's also hard to implement roll your own logic always around what if this fails and that this goes down, a node goes down here, and all of that. The pipelining stuff that we'll talk about today has all of the necessary logic around dependencies. So if you have stages A, B, C, D, E, F, G, and they're all dependent in different ways, and certain of them fail and certain of them don't fail, once you fix the code or whatever you do, only what needs to update will update, and the other things that have already run will just be as they are. And you can also access very easily the job logs and see what data was input to what that made it fail, et cetera.